here we are back with the next one. And this function, I'm working on number 4 right now. We're skipping number 3. I'll leave that one for you. With number 4, we have the function. However, I will give you the equation for number 3. This is x minus 2 squared minus 4. That's this function for number 3. But number 4, this function is negative 2 x minus 3 squared plus 4. So we're actually going to look at this one on this calculator here. Make sure that that function actually works. Negative 2 x minus 3 whoa, that's not a squared. Squared plus 4. Huh? Done. Matches. Good. Okay. So we've got the function. Let's start to define it. Remember I said that domain, x-intercepts, and minimum/maximum tell you just about everything you need to know. So for the domain, and I'm just going to write these in this column, even though remember, this is number 4, not number 3. Number 4 you might write over here. You know what? I'll do that. Domain, range, x, y, minimum, maximum, and we'll do the rest later. And it's later. Okay, so the domain. The domain, I told you in the last one, for these quadratics, it's always going to be negative infinity to positive infinity. When would it not be that? If I was dealing with something like the square root of x, look at my table here. You see how it says error, 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 error? All the negative numbers get errors. And that's because when you take the square root of a negative number, you don't get a real number. And so that would be a domain of not all real numbers, only positive real numbers. But we don't have to worry about that just yet. I just thought I'd give you an example of when it wouldn't be that. So always negative infinity to positive infinity for the domain, because x can be whatever it wants to be. Y, however, cannot be whatever it wants to be. These values do go down in the negative direction forever, which means there is not a minimum value. Minimum, none. Which means the range goes down to negative infinity. However, there is a maximum value. Where does it occur? It occurs at 3, 4. Let's write that here. So 3, 4 is the maximum value, which means the range is negative infinity to 4. Okay, let's do the y-intercept because like I said before, that one's kind of it's not really involved in any of the other things. So how do you find a y-intercept? Like I can't see where it crosses the y-axis. It does it somewhere down there. One thing you could do is FOIL that out, this whole equation, and find out what the constant term is at the end, the number. So it's not 4, but there will be a different number at the end. And that would be the y-intercept. Judging from what I've seen, we will not do that well with high enough accuracy. Let's go to the calculator and see what it says. There's a couple ways to find it, but I think the easiest way is hit second and graph, and you'll find yourself in the table. So what's the definition of a y-intercept? It's the y value when x is 0. So we find the x column, we find 0. What's the y value? Negative 14. Y-intercept, 0, negative 14. Give it to me as a point. All right, we're ready to move into some other stuff. Use this dark green color. Sounds like a great idea. Let's talk about, we got the maximum and we know the domain. So that's prime time to do intervals increasing and decreasing. Because again, a maximum is when the function stops increasing, it increases until that point right there, and that's when it turns around and it starts decreasing. So we want to say when that happens, when exactly is the function increasing, when exactly is the function decreasing. And when questions are answered with x values. Okay. So the first interval, if you hadn't picked up on it, starts with negative infinity and goes until the maximum point, 3. What's happening during that portion? It's increasing, negative infinity to 3. Okay, cool. So if it stops increasing, the only other option is that would be decreasing for quadratics. So at 3, it starts to decrease. And does it ever stop decreasing? No, it decreases forever, and that's until x gets to infinity. So if x was 1,000, there's always 1,001. If it's 1,000,000, there's 1,000,001. And every single time you increase the x value, this function will have a lower y value than it did before. So that is intervals increasing and decreasing. Again, we are done with that portion. So, darn, didn't need to erase negative infinity. It matters still. So now let's look for the x-intercepts, because the x-intercepts are going to go with intervals positive and negative. So an x-intercept would be these 2 points right here when it crosses the x-axis. And that is the moment a function stops being negative and starts being positive, or the other way around. So on this side, I would call this portion number 1 of the graph. The function's in the negative region. It's down below the x-axis. This portion right here, portion number 2, that's all of this. The function is positive. It's above the x-axis. And then this region down here, I'll call region number 3. It's below the x-axis again, so it's negative. So you'll have 2 intervals where it's negative. You'll have 1 interval where the function's positive. Let's find out when it is. So we can't answer that question until we know these x-intercepts. There are 2 of them, and we will use the calculator to find them. The x-intercept happens when the x value of a function is, or when the y value of a function is 0. So we could solve for both of these. If you plug a 0 in for this y value, you would subtract 4, divide by -2, take the square root of 2, and you would have those 2 answers. We'll find them in decimal form with the calculator just for practice. You can hit second and trace. It should take you to this calculate screen, because that's what it says in the little blue letters, calc. We want to go down to, 0, because that's an x-intercept. And then it says left bound. You're like, where's my cursor? The blue, 0, -14, that tells you where it is. It's just a little too low for me to see right now. There it is. Okay, so the first point is right around there. That's not the point. See how y is not equal to 0 right now? That's not the point. It's just close. So it says left bound. We want to hit the left arrow key until we're on the left side of the point we actually want. And we hit enter. Then we go to the right of that point and we hit enter again. Now it says guess, which I think is an unnecessary step for the calculator, but it is there. We hit enter one more time and it says 0. The x-intercept is 1.586, 0. 1.586, 0. And I'm just getting 3 decimals to prove that we're not just eyeballing this thing. Because I think you would probably look at that and say, oh, that's about 1.5. But it's 1.586. And sometimes that matters. All right, let's find the other one. Same steps, second trace. It's a 0 as well. I'm going to take my cursor to the right until I get really close to that point. See how y still isn't 0? That's because I haven't told it where to look yet. We're going to go to the left side now and hit enter. We're going to hit right, go past it and hit enter again. So now we were on the left side, then now we're on the right side. Hit enter one more time. 4.14, 4.414, 4.414, comma 0. That is the other x-intercept. So let's run our way down to the graph. This is 1.58 and this is 4.41. And we are ready to do intervals positive and intervals negative. So we start off with a negative interval, right? That's section 1. It's below the x-axis. That's negative y values all over the place. So starting with negative infinity, the y values are negative. And they stay negative until that point, 1.58. At 1.58, the y value is 0, which isn't positive or negative. It's just that turning point from negative to positive. So now we're in the positive region. Again, 1.58 is where we'll start. So you see how we do this little back and forth thing? Negative infinity, 1.58. 1.58 until when? Until 4.14 or 4.41. I want it to be pi so bad. 4.41, the function is positive, but 4.41 is where it's 0 again because it's changing. It's changing from the positive region now down to the negative region again. And does it ever stop being negative? No, it stays negative forever. So rocking and rolling, we just have in behavior left. In behavior left to do. Left side and right side. Your domain and range kind of help you with this, domain and range. So the in behavior, these are your x values, negative infinity, positive infinity. This thing goes left and right forever. So on the left side, sorry, that was the sound of disappointment in myself. X goes in the negative direction forever. On the right side, the x values are going in the positive direction forever, getting more and more positive. Well, what's happening to the y values during that time? Remember on the last video I said these will both be the same. They'll either both be positive infinity or both be negative because it's either pointing down on both sides or pointing up on both sides. And it's pointing down. That's the negative direction forever. You're doing a great job. Those are two of the longest videos. Those are two of the longest problems. We'll pick back up with the next section, solving